Hello and welcome. In the next couple of videos, I'll be talking about intermediate programming, solving problems, higher complexity programs, and the art of troubleshooting that is often frustrating but necessary. First, some motivation. I think it's really important to know that when you're learning to program, uh, cognitive effort or struggle is part of the process. And there's a lot of research that shows that cognitive effort, though it might not be so pleasant, is important for learning. It's really part of learning. And even great scientists like Einstein and Curie, they struggled while learning. And interestingly, knowing that has been shown to help people learn as well. And I think it really shows uh, a basic thing about learning, which is that if you don't struggle, you kind of don't learn, and that it's really a step in the process. So I want to say this sort of as motivation. And when you're stuck, it's really important not to shut down, right? To just keep trying to break down the problem, understand it better. And in the next few videos, we'll be discussing strategies for how you can do this, how you can stay engaged, and even when you have no idea where to start, which is very common for everybody. A comment about the pace of this material. So you might be feeling overwhelmed, especially if you have no programming experience at all. And that's to be expected, right? This is a completely new way of thinking. And I get that it takes a huge leap of intuition to go from seeing a lecture slide, to being able to implement these things in practice. And my suggestion is, we have these exercises, go through them in their entirety, right? So don't just skip to the problems. The exercises are meant to build on the lecture. So there is not much, but like a few new, some new information that is introduced in the tutorial sections of these exercises. So you shouldn't need to know anything that is not covered in the exercises, in the tutorial sections of the exercises or the lectures. But you will need to work to kind of know when to apply these things. And I understand that that's not easy, and that it takes a kind of leap of intuition to do that. So work at your own pace, and work overtime if necessary, right? You have the entire afternoon and evening to work on these things. And we could require for this course preliminary reading and additional preparation, but we don't. And this is to give you extra time to work on these things if you need it. Also note that the notebooks are yours forever, right? So make them yours, change them, and feel free to break the code. You have the link still if you want to make a new one. You're not going to mess up the master version or anything like that. So feel free to play around with these notebooks, and to really try to understand and take things apart, dissect them. And again, I can't reiterate this enough. Cognitive effort is super important and essential in this process. So if you feel effort, if you feel like you're struggling, don't be frustrated by that. Take that as a sign that you are making progress. Some guidance for those who are feeling underwhelmed. So if you're attending this course and you're feeling like you already know this material, my first suggestion is be patient, because this is a bioinformatics course and we're going to go through bioinformatics topics. Knowing how to program, introductory program, is not a prerequisite for this course. So that does set the pace for the material. And it means we do have to cover introductory programming, because the majority of people in this program do not have introductory programming experience. So if you are someone who already knows how to program, my suggestion is to study independently. So there's a lot of topics that could complement the material of this course. You could study protein folding prediction, next-gen sequencing, data processing, anything related to coronavirus, phylogenetics. Also, do the optional challenge problems. So we include these and make them as open-ended as possible for a reason, and that's to encourage you to, you know, put your own spin on them, right? Try to make them useful or interesting to you. The effort that goes in, is what comes out. If you haven't, take a second to reflect on, the things you learned in the last few videos, and were there any tricky or confusing points? I'm sure for many there were. So if so, try to articulate these in your mind. What was it exactly that gave you trouble? And in the next few videos, I hope that some of this will start to become clearer to you. And a lot of it is exposure, right? It's only been one day, and you have to be patient and determined to absorb this material. So try to locate your weaknesses and address them where you can. So yeah, let's review. We have these basic programming elements, and they're super fundamental. We have to know how to do these things, what they are, because at some point very soon we're going to be connecting them, piecing these things together. So what are they? Let's review. We have loops, right? For loops, for example. Loops are a way to repeat a calculation, and this is most of what programming is, right? Performing iterations, iterative operations. And when you have a loop, you have a particular syntax, right? We use the word for, and we have this variable afterwards called the iterator. And usually people write it as I, but it can be anything, right? And the iterator is going to change. It's going to take on the values of the list that we feed it. So if we feed it a list that's just a range of numbers from 0 to 13, for example, then the first time through the loop, I is going to be 0, and then it's going to be 1, and then 2, and so on until 13. So this can be a way to simply repeat a calculation 13 times. On the other hand, we could provide as our input list something else, some other sequence. We can even supply a string, right? You can do loops on characters and strings, because that's also a sequential type of data. And the iterator in that case will take on the values of those characters, those letters. Sometimes you use the iterator in the block of code that's within the loop. Sometimes you don't. Conditionals. So this is also super fundamental, right? Conditionals are a decision, a fork in the code. And you check if some condition is met. Is some value equal to 2? If so, do the following. If not, do something else. 1D data structures, right? And this is connected to loops, of course. We got strings, lists, and NumPy arrays. Those are the main ones, right? Strings are text, right? They're a series of letters or characters. Lists, square brackets with comma-separated objects, and you can have lists within lists. You can have lists of text, lists of numbers, lists of floats or integers. You can even have mixed lists of some numbers, some strings. NumPy arrays, right? For this, we need to import the NumPy module or library, and we make an array by using the numpy.array function. Why are these important, right? 1D data structures, these are in 9 times out of 10 going to be the data that we're working with. So if we're processing genes or processing sensor data from an instrument, usually this is going to come in the form of a series of numbers or a series of sequences. So being able to use a loop, for instance, to perform operations on one of these input lists of data is going to be a lot of what we're doing in scientific computing. External modules. So yeah, we mentioned NumPy just now, but you should know about Matplotlib for making graphs and visualizations, the math library for basic, if you want to compute a square root, something like that, Bio or BioPython. These libraries, we're going to use them more, but remember that they're out there and that depending on your problem, you may need a particular library to solve it. So quiz question. How do we return the last sequence from the following list? So this is just a bit of review. So we have this list here of 5 DNA sequence strings here. And let's look at this. So, and we can make, for example, something similar. Let's just make these a bit shorter for our own convenience. 1, 2, 3, 4. Let's do one more. Last one will be GGG. Okay. So let's try this. If we try to fetch, so let's look at option A first. Like, let's just include the first set of indices here. And we see that this is a range, right, from 2 to 5. And the convention is, of course, you do from item 2 up, but not including 5, right? This is the convention. So this will fetch items 0, 1, 2, 3, and 4. And note that we don't have, an item 5 here. So if we, if we try to fetch, for example, and this can be a bit confusing, if we try to fetch item 5, we get this error, index error, list index out of range. But if we supply a range from 2 to 5, then it's going to work because when we're using a range, we're not including the last number here. So that's the first part here, but item A, you can see, also has another appended index here, item 2. And if you think about it, this will fetch the last item in the original list because we have items 0, 1, and 2 in the list that we produced here. So if we fetch item 2, that's going to be the last item of this 3-element list, which is also the last item of the original 5-element list. So item A here is correct. How about B? So this is quite similar, but here we're doing another range, and we're starting from item 4. So 0, 1, 2, 3, 4. And we see that item 4 is in fact the last item. So if we have a range that is from 4 up to, but not including 5, then that is only going to be a range of 1 item. So we see that B also is going to give us the last item. So that's also correct. Item C, a -1, counting from the end, that's always going to be the last element. So C is also correct. And then last but not least, item D here is going to just fetch item 4. So we have 0, 1, 2, 3, last item 4. So the correct answer to this would be all of the above. How do we return the first 2 elements of row 3 of the following multi-dimensional NumPy array, assuming there is a row 0 at the beginning? Okay, so let's take a look at this. We have a NumPy array. Let's call it array 1. And of course, we need to import NumPy. And we'll make our array with the array generating function. And let's just make something simple. 1, 2, 3, 4. And let's say 0, 1, 2, 0. Whatever. Let's do something different. 10 and 20. 30. 40. Okay. So we have a NumPy array. Oops. Let's see. 0. Yeah, so of course, the mistake I made here is we need to enclose this. Since this is a list of lists that we're feeding it, we need to have brackets on the outside as well. So let's take a look at this. So if we try the first option here, we want, let's see. Okay, and actually let's include some more. Let's make this more like the actual problem. So we have actually 4 rows here. Yeah, whatever. Let's see. Let's make this decimals, just so they look a bit different. Okay. So we have a 4-row multi-dimensional array here, and let's say we use the square brackets index. What is this going to give us? So, and actually maybe it helps to print first the array to see a bit what it looks like, right? So it's got 4 rows here, and also 4 columns. This is a 4x4 matrix, basically. So if we pull item 3 from this multi-dimensional array, this is going to give us row 3. And again, we're starting from 0, so we have 0, 1, 2, 3. So that's going to be the last row here. Let's see, we want the first 2 elements of row 3. So if we want the first 2 elements, then yeah, we can do as option A here, 0, but not including the range of 0 up to, but not including 2. So that should fetch us item 0 and item 1. So that will be the first 2 elements of row 3. So A, looks like A is correct. Let's try, so this is a NumPy array, which means we can use commas. So instead of using just concatenated or appended indexes, we can use kind of matrix notation here, row 3, and then the range 0 to 2. This should work as well. So B is also correct. But we can also use a combination of these. So we can use the comma strategy to get row 3 and everything up to, but not including item 2. And on top of that, we can append another index. Everything up to, but not including 2 is just going to be the same, the same information here. So C is also correct. Let's give the last one a shot. So, right, if we have just a colon, that's indicating all of, whatever that is. So if we abide by the convention row and then column, Roman centurion, we have row 3, all columns, right? So that's going to be, right, row 3, and then all columns of row 3. And then from that, we can fetch, for example, everything up to, but not including 2, the first 2 elements. And we could also, for no particular reason, include another index that just indicates we want everything, a colon. So this is still, it's not changing anything to add this last thing, but this is still going to give us the first 2 elements of row 3. So again, here, all of the above would be the correct answer. Okay, here's another one. Consider the array loop below. What will the final array look like after the loop has completed all of its operations? So we have NumPy here. We're creating an array, array 2, composed of zeros, 10 zeros, because we're using here the NumPy zeros function. And we have a for loop. So for I in range 0 to the length of our array, so this is just going to be this range generator here is just going to generate integers 0, 1, 2, 3, 4 up until, but not including 10. and I is going to take on those values. And then here we have inside the for loop a conditional, and it says that if I is less than 7, then perform this operation. Array index I is going to be equal to 1. So this means that for the first, for 0, 1, 2, 3, 4, 5, 6, and that's 7 items that I just named, the first 7 things are going to be set to 1 then, right? Because I is going to be taking on values that do satisfy this condition initially, less than 7. And then those indices, 0, 1, 2, 3, 4, etc., are going to be used to access a position in this array. And then we're setting whatever that is equal to 1. So initially, it's just a bunch of zeros. But then we're going to say, say, if we're on, iteration number 3, I is going to be equal to 3. So we say array position 3 is equal to 1. So already we can kind of narrow it down. It's probably not going to be D here. And then we have an else clause here. So if I is greater than or equal to 7, basically, so if it's not less than 7, then do this, set array position I equal to I. So basically we just have to count. So it looks like it's going to be one of these two, right? So 0, 1, 2, 3, 4, 5, 6, and all of these are less than 7, right? But as soon as we get to I equals 7, that's going to start triggering the else condition. So it looks like then that B is the correct answer, but it's easy to make a mistake here. So because I'm not sure myself, I think we will just try implementing it. So let's try this. Pi.zeros. Colon, if I is less than 7, do array 2, position I, set it equal to 1, and an else clause here. And here we set it equal to I. So let's just see what's produced when we call array 2. So yeah, looks like B is the correct answer. And I'm going to end this video here. So see you in the next one.